Howdy! In this mini lecture, we will continue discussing conventional alternatives to fossil fuels as an energy source. Specifically, we will discuss bioenergy and hydroelectric power. The student learning objectives of this mini lecture are: describe the major sources, scale, and impacts of bioenergy, and describe the scale, methods, and impacts of hydroelectric power. Let's now discuss another conventional energy, bioenergy. Bioenergy or biomass energy is the energy obtained from biomass. Biomass is organic material derived from living or recently living organisms such as wood, charcoal, agricultural crops, and manure. Over 1 billion people use wood for heat, cooking, and light. This occurs mainly in the developing countries. In developed countries, we use bioenergy for biopower, which is when biomass sources are burned into power plants to generate heat and electricity. Many types of biomass are combusted to generate electricity. Common sources of biomass for biopower are waste products of industries or processes such as woody debris, pulp mill waste, and crop residues. Other waste sources for biopower include animal waste from feedlots and organic waste from landfills. Up to 15% of the coal in some coal-fired power plants can be replaced with biomass, such as wood chips, to allow the plant to generate energy with less pollution. The process of incorporating biomass into coal-fired power plants is called co-firing. Co-firing is a relatively easy and inexpensive way for utilities to expand their use of renewable energy. We also harness biopower through gasification, which is when biomass is vaporized to create a gas that can be burned as a fuel to generate heat and electricity. Currently, much of the biopower produced comes from power plants that use cogeneration, which is when the excess heat produced by a power plant is captured to heat nearby homes and offices, as well as to produce other kinds of power. Bioenergy crops are usually fast-growing plants like willow trees, bamboo, and switchgrass. As Table 20.3 in this slide illustrates, there are a diversity of bioenergy sources, which means we have a variety of ways to address our energy challenges. However, it's important to consider the source of biomass as we evaluate the sustainability of this type of energy source. Biomass is renewable only if it is not overharvested and if the sources invested to grow the biomass are from sustainable sources. Overharvesting of biomass sources causes deforestation, erosion, and desertification. Biomass energy can also be used to create biofuels, which are liquid fuels used to power automobiles. The two main types of biofuels are ethanol and biodiesel. Ethanol is a biofuel made by fermenting carbohydrate-rich crops such as corn. Ethanol has been added to U.S. gasoline to reduce emissions. In 2012, over 13 billion gallons of ethanol were made in the U.S. from corn. Ethanol production is experiencing a huge boom in production, largely due to congressional mandates to increase ethanol production. About 40% of U.S. corn goes to making ethanol for fuel. Ethanol is mixed in with gasoline up to 10% by volume. However, some vehicles are being produced to run entirely on ethanol. There are also flexible fuel vehicles that run on E85, which is a mix of fuel that is 85% ethanol and 15% gasoline. While there are 9 million U.S. cars that use E85, most gas stations do not yet offer this fuel. While ethanol may seem like the golden solution to our energy problem for the transportation sector, what few do not realize, including most of Congress, is that growing corn for ethanol requires nearly as much energy as it produces, and there are other significant environmental impacts of growing corn for fuel. Specifically, growing corn impacts ecosystems because we have to convert natural land to agricultural land. Ethanol production requires significant inputs of pesticides, fertilizers, and irrigation. Ethanol competes with food and drives up food prices. And growing corn requires fossil fuel inputs for equipment, pesticides, fertilizers, and transportation to processing plants. When you consider all of these costs associated with ethanol, the energy returned on investment, or EROI, ratio is about 1.5 to 1. This should tell you that ethanol is incredibly inefficient as an energy source. The other type of biofuel is biodiesel. Biodiesel is produced from vegetable oil, cooking grease, or animal fat. The oil or fat is mixed with small amounts of ethanol or methanol in the presence of a chemical catalyst. Biodiesel reduces emissions, has good fuel economy, is non-toxic and biodegradable, and costs a little more than gasoline. Biodiesel can be sustainable depending on the oil used. While oil from cooking oil would be sustainable like ethanol, most biodiesel comes from earmarked crops, which means that biodiesel has many of the same problems as ethanol fuel. While conventional ethanol and biodiesel have their downsides, novel biofuels are being developed to eliminate some of the problems associated with conventional biofuels. For example, algae are now being used because they produce lipids that can be converted to biodiesel. The carbohydrates algae produce can be fermented to make ethanol. Algae can also be used to develop a variety of other fuels. Algae grow fast, can be harvested every few days, and can be grown in ponds, tanks, photobioreactors, or in vertical growth setups. Another advancement in biofuels is cellulosic ethanol. Whereas ethanol production requires the use of a food crop, researchers are refining methods to produce ethanol from structural plant material that has no food value, such as corn stalks. If this process was developed to the point of commercialization, we could make ethanol from low-value crop waste such as corn stalks and corn husks, rather than from high-value crops. This would mean we wouldn't have to grow our fuel. Rather, we could just put the waste product from a food source to better use. There are some benefits and drawbacks to biopower. Biopower increases efficiency in waste recycling. It reduces CO2 emissions and it reduces sulfur dioxide emissions when used to replace coal. However, burning crops in areas away from where they originally are grown deprives the soil of nutrients, which means the soil is progressively depleted. Then there is the question of whether or not bioenergy is carbon neutral. In principle, biomass energy releases no net carbon. However, in practice, burning biomass is not carbon neutral because if the forests are destroyed for cropland to grow bioenergy crops, or if fossil fuel is used in the cultivation of the crops through fertilizers, transportation, use of tractors, or use of pesticides. It should then not come as a surprise that international climate change policy does not encourage bioenergy approaches because in practice they are not sustainable. The final conventional energy alternative we will consider in this mini lecture is hydropower. Hydropower uses the kinetic energy of moving water to turn turbines to generate electricity. There are three approaches to hydropower: the storage technique, the run-of-the-river technique, and the pumped storage technique. In the storage technique, water stores in reservoirs behind dams and then passes through the dam and turns turbines. The storage technique provides a steady and predictable supply of electricity even when natural river flow is low. Large dams can provide a substantial amount of hydroelectric power. The run-of-the-river approach generates electricity without disrupting the river's flow. Water is diverted from the river via a pipe or channel. The water flows through a powerhouse, which contains a generator and turbine, and then the water is returned to the river. This method is useful in remote areas away from electric grids. The downside of this method is that the electricity generated is less reliable because you can't guarantee reliable water flow. The benefit of this technique is that it minimizes impacts that come with damming a river. For example, the run-of-the-river approach doesn't alter existing flow or water levels. The pumped storage approach is when water is pumped from a low reservoir to a high reservoir and flows downward through a turbine. The water is typically pumped up to the high reservoir when demand for power and electricity prices are low, such as during the nighttime. Then when demand and prices are high, water is allowed to flow downhill through the turbine to create electricity. This would likely be during the daytime. The pumped storage approach can help to even out power supply when paired with intermittent sources like solar and wind power. Hydropower has some clear advantages over fossil fuels for producing electricity. It is renewable. As long as precipitation fills rivers, we can use water to turn turbines. And it is clean, meaning no carbon dioxide is emitted when we generate electricity via hydropower. Hydropower is efficient. It has one of the best EROI ratios at 100 to 1. For reference, coal is about 80 to 1 and oil is about 11 to 1. But there are some significant disadvantages to hydropower, as we've discussed before. Damming rivers destroys wildlife habitats. When dams are built, upstream areas are submerged and downstream areas are starved of water. Natural flooding cycles of rivers are disrupted. Downstream floodplains don't get nutrients. Damming causes thermal pollution. And dams block passage of fish, fragmenting the river and reducing biodiversity. While dams have helped many nations such as Canada, Brazil, Norway, Austria, Switzerland, and the U.S. develop, hydropower isn't likely to expand much more because most of the world's large rivers have already been dammed. Specifically, 98% of U.S. suitable rivers have been dammed and the rest are protected. Furthermore, people have grown aware of the ecological impact of dams. There is now a movement to eliminate dams and restore streams to their natural state. That concludes the second mini lecture on conventional energy alternatives. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!